Now onto the pH scale and pH calculations. That's the big pH formula. pH equals negative log H3O plus concentration. Now, for our purposes, we don't really need to understand how logs work and calculations involving logs. In chemistry, all that log represents is a button on the calculator, so don't stress too much if the thought of logs scares you a bit. We transpose that formula, and H3O plus concentration equals 10 to the minus pH. So just the two transposed versions of the same formula. And in essence, what the logs do is they compress a huge range of calculations. So we see the concentration of H3O plus varying from 10 molar down to 10 to the minus 15 molar. So instead of dealing with huge range of numbers like that in order to indicate how acidic a solution is, it's really useful to compress that to a simple range, and the log scale sort of compresses that to a range between -1 and 15 or so. I've seen various translations of where pH came from. I think I've also seen some people say it comes from a German phrase, very similar. And you can see the English is pretty similar to pH, hydrogen power. So just some examples of pH of different common household things. Pure water, of course, as we saw before with the ionic product calculations, the concentration of H3O plus and LH minus is equal at 10 to the minus 7, and we take the log of that and we get the pH, as you know, the pH of neutral substances being 7. That's where that actually comes from. As we get more acidic, milk is a very mildly acidic solution, somewhere around 6.5 to 6.8. There's no need to write any of these down particularly, it's just included pretty much for interest. Urine is mildly acidic, but not as acidic as coffee and bananas. We get to more of the fruits and things like that, the foods that are known to be quite strongly acidic. Tomatoes are an acidic fruit. Oranges, citrus fruit of course is acidic. Vinegar is a solution of ethanoic acid of course. Beer, Coca-Cola are all acidic drinks. So lots and lots of foods are in that acidic range. Lemon juice is probably the most acidic of the commonly eaten foods, and our stomach acid, 0.01 molar H3O plus. Go into Bunnings and you'll buy your 35% HCl and pH of -1. Very nasty stuff that. Be careful with the chemicals you buy from the hardware shop. Okay, if we look at the basic range, that means OH minus is increasing, H3O plus decreases, pH increases. So as we move up the pH scale, starting with pure water of course, blood. With all that carbonate in it, as we transport the carbon dioxides from our cells to our lungs, gives us a slightly alkaline pH. Seawater, again I think largely because of all the carbonate present, pH of roughly 8. Baking soda, which is sodium hydrogen carbonate. And now we get into the cleaning compounds. Cleaning compounds are almost always alkaline. part of a lot of their cleaning properties is their functioning as a base. So soapy water, bleach, dishwasher powder, that's quite strongly alkaline. That's why you need to be pretty careful with that stuff, keeping it away from little kids. And then drain cleaner. Again, it's just another example. You can buy that stuff probably in the supermarket, pure sodium hydroxide, and really strongly alkaline. If you dissolve it in water, got to be really careful with it. Okay, let's do a few examples of using the pH formula. Okay, simple 0.1 molar HCl, as we saw before with the ionic product calculations. With a strong monoprotic acid, H3O plus equals HCl equals 0.1 molar. So therefore pH equals negative log H3O plus. And if you press your buttons right, you'll end up with 1. Now, there is a shortcut which works, which simplifies these calculations quite a lot. Now, if you need to use the formulas every time, no problem with that, but if you can see powers of 10 easily, then the shortcut's really useful. So we know the concentration of H3O plus is 0.1 molar. Write that as a power of 10, it's 10 to the minus 1. Well, the pH is basically going to be that power, the negative of that power. And the same happens for any exact power of 10 concentration. So if it's 0.001, which we would write as 10 to the minus 3, you know, count your decimal places that you move. 1, 2, 3. 10 to the minus 3, that means the pH is 3. And so on right the way through. That is 10 to the minus 6, therefore the pH is 6. If the concentration of H3O plus is 10 to the minus 12, the pH will be 12. So like I say, that's a nice easy shortcut if you've got round concentrations like that, but you can always use a formula if you need to. Okay, however, unfortunately, this is not one of those situations. We've got a diprotic acid this time. That means we've got to multiply concentration by 2. So H3O plus is 0.2. That means we've got to use a formula. Negative log 0.2 equals 0.7. Now don't worry too much about significant figures here. The way it's written here, so the significant figures are actually the numbers after the decimal point. The first number here is like an order of magnitude. It's like the powers of 10. But like I say, we don't worry too much about significant figures in these calculations. pH of pure water. Well, if we know that H3O plus is 10 to the minus 7, then chuck that into the formula, and we'll just recognise the power. Gives us a pH of 7. Okay, let's go back the other way. You know the pH, we want the H3O plus. Well, it's very simple, 10 to the minus pH. So 10 to the minus 11.5, chuck that in your calculator and hopefully that's what you get. Very similarly here, when we've got a nice monoprotic acid, H3O plus equals HCl, so it's going to be 10 to the minus 3. Written, of course, correctly in scientific notation. The only minor complication is where we get diprotic acids. So we can use our pH formula to work out H3O plus, but then we've got to halve that to get H2SO4. So we know that H3O plus equals 10 to the minus 2.5, because that's what the pH is. Evaluate that and that's what we'll get. Now it takes 2 H pluses to make 1 H2SO4. So we're going to have half as many H2SO4s. So we've got to halve that concentration to get our H3O plus, our H2SO4 concentration. Okay, have a go at those questions, submit, and I'll get back to you with the solutions if you need it.